Find the directional derivative at 1, 1. In this problem, we are provided a function f of x, written in its quadratic form, and represented as a yellow surface in the three-dimensional plot, which varies with different values of x1 and x2. The vector x is composed of two variables, x1 and x2. And at the point of interest, both x1 and x2 equal 1. The directional derivative, df of x, is the maximum grade of the function f of x, which we'll evaluate at point x, where x1 equals 1 and x2 equals 1. The term normalized means the root sum squared of all terms in the vector x equals 1. Let's begin by returning to our equation f of x and multiplying out the terms such that f of x equals x1 squared plus 6 times x1 times x2 plus 7 times x2 squared plus 3 times x1 plus 5 times x2 plus 6. Next, we'll compute the gradient of f of x, which equals the partial derivative of f of x with respect to each of the variables x1 and x2. After computing the gradient, we'll return to our sketch of the function f of x. Next, we'll show a contour plot which looks down upon the x1, x2 plane. If we label a few of the level sets 28, 21, 14, and 7, we notice that at point 1, 1, the positive gradient points in the direction which has a positive x1 value and a positive x2 value. When pointing in the direction of maximum increase of f of x, the gradient of the function equals the directional derivative of the function. Therefore, to find the directional derivative, all we need to do is plug in 1 and 1 for x1 and x2, and our directional derivative equals 1125. Since the problem asks to find the normalized directional derivative at point 1, 1, we need to divide each term in x by the square root of the sum of each of the terms in x squared. And the normalized directional derivative equals 11 divided by the square root of 746, 25 divided by the square root of 746, which is approximately 0.402, 0.915. When reviewing the possible solutions, the answer is B.